And hello, today we'll be looking at triangles, another part of geometry. So I guess we'll get started with what are triangles. I know it might be quite a trivial question, but we see them in everyday life. For example, in your snacks, like your Doritos or your tortilla chips. You might see them in signs. Another example would be in construction. So woodwork or DCG would be looking a lot at triangles just as well as us. There's also other examples you can probably think of. One I usually think of as pizza, but technically pizza isn't one because the outside is round. But remember that triangles are 2D. So there's a difference between a triangle and a pyramid. So a pyramid is kind of the 3D version of a triangle. If you think a square is a 2D version of, or a cube is a 3D version of a square. So don't just be careful a little bit. Sometimes people get confused. Triangles are 2D, they're flat. A pyramid would be the 3D version, and the obvious example is the pyramids in Egypt. So, what are triangles? What's the mathematical definition? A triangle is a three-sided 2D shape with three internal angles. So it has three sides. What do I mean by sides? These lines. 1, 2, 3. And then it has three angles. It has this angle here, this angle here, and this angle here. So that is your definition of a triangle. So then let's look at the angles of a triangle. We have this angle here. I'm going to call it angle A. Now remember, I don't know if you've seen this before, but this little symbol, this little kind of crocodile mouth, this means an angle. So this denotes angle A. So this angle is called A. This angle here I'm going to call B, and this angle here I'm going to call C. Now, all the angles of a triangle add up to 180 degrees. And this is at the core of what a triangle actually is. And this is one of the fundamental things you have to remember about triangles. That all these guys, if I add A plus B plus C, they add up to 180 degrees. Now, you might be asking, why? Well, this is why. I've just copied this triangle and I've just kind of rotated it and I put it here. So this triangle and this triangle is exactly the same. I've just rotated it a bit and I've just stuck them down here. Now, that angle here is angle A. If you think about it, if I just rotate this guy, turn him upside down, this angle here would be this angle. So if I just kind of picked this corner and then pulled it all the way over and then moved it here, that would be A. What's this angle going to be? Well, it's going to be B. And that angle there is going to be C. Now, this is a quadrilateral. You probably will have done that before. A quadrilateral has four sides, four angles, and always adds up to 360 degrees. So I have C plus B plus A plus C plus B plus A. So that's 2 A's, 2 B's, and 2 C's equals 360 degrees. So that's a fact. All these two angles, and this angle added together 360. Now, if I divided everything by 2, I can do that. Remember, if I multiply everything or I divide everything, that's okay. So I'm going to divide everything by 2. So I divided A by 2, B by 2, C by 2, and 360 by 2. I find that A plus B plus C is equal to 360 divided by 2, which is just 180 degrees. So that means A, B, C in my original triangle, it's going to be 180 degrees. And it's really important to remember that. Then we have different types of triangles that we'll encounter, and we have names for them. We have this guy, and this guy. So, first one, equilateral triangle, is where the three sides are exactly the same and the angles are exactly the same, and the angles are going to be in this case 60 That's the only time all the angles can be the same, because think about it, they all have to be the same and they add up to 180. So 180 divided by 3 is 60. So 3 sides. So if that length was, I don't know, 5 meters long, this would be 5 meters, this would be 5 meters, and then all the angles are the same. Next one, isosceles, that's how you say it, isosceles. The side lengths, so 2 sides are equal. Now they're denoted by this little line. So over here, all these sides had this little line going through it. Now this time there's only these 2 lines, so these 2 sides are the same. And then the 2 angles with those sides are also going to be the same. And then this angle here is going to be different, and this side is going to be different. So how do I know which angles and which sides? If I know the sides, then I know that across, so this is a side, across from the side, that angle, this side, across from that side, this angle are going to be the same. So I think cross, and they're all going to be the same. So this side is going to be the same as this side, this angle is going to be the same as this angle. The weird angle, or the odd one out, this angle here, well, the side across from that, this side, is going to be different. Then scalene, which is the ugly duckling, everything is different. So this angle is not the same as this angle. They're all different angles, and all the sides are different. So those are the 3 types of triangles. They have to be one of those 3, and you have to know the names and the properties of all those. So if you want to spend time looking over them now, you can pause and have a think about them, but you got to remember all of them. Then the last kind of important triangle we have to think about is called a right angle triangle. So we've spoken a little bit about right angles before. A right angle triangle has one interior angle that is 90 degrees. Now the question is, which one of these is 90 degrees? Is it this one, or this one? Well, you remember the box indicates 90 degrees. So this angle here, if you think about it, if I continue that line straight going all the way out there, that would be 180 degrees. But instead I've taken a sharp perpendicular turn, and that's going to be 90 degrees. Then what about the exterior or the outside angle? So this angle here, let's say. So I have the angle inside here, but what about outside the triangle? Is there anything we can denote about that? Well, I know this angle is 50 degrees. How did I get that? Remember how many degrees altogether in the triangle? 180. So 70 plus 60, that's 130 degrees. So what's 180 minus 130? Well, this is going to be 50. So what's that going to be? Well, that's going to be 130. Because remember, this is a straight angle. If I add this and this, it's going to be a straight line. So that's also 130. And how did I get that? Well, again, 180 minus 50. It turns out, though, you notice, remember these two added up to 130, and that was also 130. Well, that's always going to be the case. These two are always going to be the same as D, because C and D add to 180, and A and B and C add to 180. So the exterior angle, this angle kind of outside the triangle, is equal to the sum of the 2 adjacent interior angles. Now that's a lot of words. All it means is this exterior angle, there's an angle inside, not this guy. The other 2 angles are, if I add them together, A and B, they're going to be the same as D. So not C now. D is equal to A plus B. Okay, here are some recap questions. You can pause and do them. So the first one, this is an isosceles triangle. Find the other 2 interior angles. So, looking at the triangle, which 2 sides are the same? It's kind of obvious. It's going to be these 2 sides, because it's hardly going to be this side. It's very small. These 2 sides are quite long, so they're going to be the same. So if these 2 sides are the same, remember what I said, it's the angle across from them. So this side, what's the angle across from it? Well, it's over here. So that's going to be 64 degrees. And then we were already told that's 64 degrees. So if this is 64, this is 64, well, what's that going to be? Well, it's going to be 180 minus 64 minus 64, because remember, all these added together equal 180. So it's going to be 52. That's going to be 52 degrees, because if I add 52 to 64 to 64, that's going to be 180. What type of triangle is this? What is the value of D? Well, straight away, I see my little box, so it's going to be a right angle triangle. That's also telling me that this is 90 degrees. If this is 30, that's 90. So 30 plus 90 is 120. And I'm looking for D. Well, think about it. I know that's 60, because 30 plus 90 plus 60 is 180. But I also know that D is the sum of these two. Remember we said that? That's this. The sum of the two interiors is equal to the exterior. So I know that D is equal to 30 plus 90, which is 120. I have also could have found that if I knew this is 60. Well, 60 plus this is equal to 180. So that's going to be 120.